Hi students, welcome to today's class. Today we are going to start module 2 of computer architecture and microcontroller. So this module 2 includes first topic is what is microcontroller and what is embedded processor and difference between these two and some applications of microcontrollers. Okay, the next topic we study about 8051 pin configuration and 8051 architecture, 8051 block diagram, that is block diagram architecture are same. Then different registers used in 8051 and internal memory, timers, port structures, interrupts. These are based on 8051. Then we are discussing about addressing modes of 8051 and detailed study of instruction set of 8051. These are the topics of module 2. Okay, now we can learn each topics in coming sections. Okay. Now first, what is microcontroller? We all know about what microcontrollers. Okay, that what's microcontroller? Microcontroller in the main difference between microcontroller and microprocessor is microcontroller is application specific. That means we are using microcontrollers for specific applications, but microprocessor is not application specific because we can use multiple applications. When we want to use multiple applications, we use microprocessor. Okay, now the definition of microcontroller is a device which contains the microprocessor with integrated peripherals like memory, serial port, parallel port, timer, counter, interrupt controller, data acquisition interface like ADC, DAC, etc. And microcontrollers are dedicated to one task and run one specific program. Okay, so it dedicated to a single task or it is application specific. So microcontroller is an integrated peripheral, or microcontroller is a microprocessor which contains memory, serial port, parallel port. These all components inside embedded in a single chip, that is called a microcontrollers. Okay, and it is program specific or it is application specific. Program is stored in ROM, that is read only memory, and generally does not change. Microcontrollers are often lower power devices, that is milliwatt. Okay, it's a lower power devices. Since it is application specific, it is lower power devices. Okay, microcontrollers are embedded inside some devices, often a customer product, so that they can control the features of the product, features or actions of the product. Okay, so another name of microcontroller is therefore embedded controller. So some devices are embedded inside the microcontrollers. Okay, so consumer product is some features or actions or a specific task which are embedded in the microcontroller. So it is called embedded controllers. Okay, now we can discuss some applications of microcontroller. Applications include home applications like washing machine, because washing machine is doing only a specific task, that is washing clothes. Okay, refrigerators, microwave oven, calculators, keyboards, printers, modems, etc. These are applications come under home applications. The next application is industrial controllers, which include data acquisition industries and data acquisition system, communication system, etc. Okay, so these are industrial controllers. The next, automobile engines like we are using flight control system, traffic light control system, etc. are used are the applications of microcontrollers. Then last is military application. Military purpose also we are using microcontrollers. Okay, so these are the some applications of microcontrollers. Now going to different major fundamental difference between a microcontroller and a general purpose microprocessor system. So this the first figure shows the figure of general purpose microprocessor system, and the second figure shows a microcontroller system. So from this figure it is very much clear that the both contain same devices. That is, in general purpose register there is a general purpose microprocessor or a central processing unit CPU. So also in the same time we have microcontroller, also there is CPU. Also RAM, ROM, input output port, timer, serial port, okay, serial communication port, etc. also in the microcontroller unit. But the only difference is that in microprocessor, these unit, that is RAM, ROM, IO port, timer, serial communication port, etc. are connected with the CPU by means of data bus or address bus. Okay, but in the case of microcontroller, these all devices like CPU, RAM, ROM, IO devices, ADC, DAC, timer, serial communication port, these all are integrated in a single chip. So this is the difference between, major difference between microcontroller and general purpose register. So general purpose microprocessor. In microprocessor, all the devices are externally connected by means of buses. But in microcontroller, these all the devices are integrated in a single chip. Okay. Now we can discuss the comparison between microprocessor and microcontroller. So first comparison is nothing but its definition. A microprocessor contains ALU, register and control unit. Microprocessor based system requires more hardware such as RAM, ROM and IO ports to function. Okay, so these are externally connected by means of buses. In case of microcontroller, it contains circuitry of microprocessor and in addition it has built-in RAM, ROM, IO devices, timers and counters. So it is available on a single chip. Case of microprocessors, only ALU register and control unit is included in the microprocessor, but all other devices like RAM, ROM and IO ports are connected externally by means of data bus and address bus. But in microprocessor, all the devices, that is RAM, ROM, IO devices, timers, all are integrated in a single chip. Okay. So the second difference is it has many instructions to move data between memory and CPU. In order to transfer data from memory to CPU, it needs a lot of instructions, but in the case of microcontroller, it has one or two instructions needed to move data between memory and CPU since all the devices are within the chip. Okay. Now the third point is it has one or two 2-bit handling instruction, but in case of microcontroller, it has many bit handling instructions. The handling instructions are 1 or 2-bit, but here in microcontroller it has many bits to handle the instructions. Okay, then the fourth point is access time for memory and IO devices are more since they are externally connected, but less access time for built-in memory and IO devices. Okay, so microprocessor, the devices are externally connected since it takes more access time, but in microcontroller all the devices are inbuilt to the in all the devices are inbuilt to the in the chip, so the access time is less. The fifth comparison is microprocessor based systems is more flexible in design point of view, but in microcontroller it is less flexible in design point of view. Flexible means if you want to change any system, any hardware from the microprocessor, it is very easy because all the devices are connected externally. So we can change or replace the system, that is we can replace RAM, ROM, etc. But in the case of microcontroller, since all the elements are inbuilt in the chip, in a single chip, it cannot, the flexibility is very less, so it cannot be replaceable. Okay. So the sixth point is it has a single memory map for data and code, but in microcontroller it has separate memory map for data and code. So since it has separate memory for mapping data and code, the simultaneous mapping of data and code will be take place, so the access time is increases. Okay, speed increases. Okay, then the seventh point is less number of pins are multifunction, but here more number of pins are multifunction. Multifunction means some pins are used for different functions. Okay, so the multifunction pins, the number of multifunction pins is less in microprocessor, but it is more in microcontroller. Then next point is it is useful for general purpose applications that allow you to handle lots of data. It is useful for application specific system. So it's also a definition that is in microcontroller is application specific, but this microprocessor can be used for different applications. Okay, then ninth point is it increases the overall cost of the system high. The overall cost of the system is less. Since in microprocessor we need a lot of devices to be connected externally, the overall cost will be high. Then, due to external components, the total power consumption is high. Therefore, it is not ideal for the devices running on stored power like batteries. Okay, at the same time, in microcontroller, as external components are low, total power consumption is less, so it can be used with the devices running on stored power like batteries. So, microcontrollers can be worked by using batteries, but in microprocessor it is not work using batteries. Okay, then the last point is microprocessors. It's complex and expensive with a large number of instructions to process, but in microcontroller it's simple and inexpensive with a less number of instructions to process. Okay, so these are the main difference between microprocessors and microcontroller. So that's all about the class. Thank you.